I'm very pleased to welcome our distinguished speaker, Paul Jacobs, who's joining us today. Paul, as you know, is the CEO of Qualcomm, a company that he started with his father many years ago, and one that he has made many, many contributions to technically as well as from a management and business perspective. Before I start in introducing Paul, I'd like to make another announcement, which is many of you are probably familiar with our CITRIS headquarters building. For those who haven't seen the latest rendering, that's the building. This is looking at it from the O'Brien side, from the School of Journalism side. So that's Corey Hall up there on the top left. You can see the roof sticking out a little bit there. And on the left is the Naval Architecture building, just to sort of orient you a bit. You'll notice that down here, in this area in here, we have what we call the Cyber Cafe. And the Cyber Cafe is hopefully the social heart of the College of Engineering once this building is built. The building, as you know, is starting out, going out for bid at the end of next month, and hopefully we'll be starting construction in January. But I'm very, very pleased to announce that Qualcomm has decided to name the Cyber Cafe and is making a commitment of many millions of dollars, the first check coming this year, and we'd like to thank them very, very much for that. And much of this is, of course, as you can imagine, Paul's doing, and I think it's because when he was here, he really wanted that latte, and he couldn't get it, so he's making sure you all do. And I also should mention that Pete's Coffee we're negotiating with to actually run the Cyber Cafe for us, and the goal is to make it a 24-hour access, plenty of caffeine kind of location. So keep you all going. So I'm really, really excited about this, and thanks to Qualcomm, thanks to all of our alums, many of them down there, and all of the other staff at Qualcomm that have worked hard with us to make this possible, and of course especially Paul. It's a fantastic development. So we're going to continue to work very closely with Qualcomm and continue to keep them very actively involved in our college, working as hard as we can on that. And this view from the top talk is one step in that direction. We'll see a lot of projects. We already have a lot of projects ongoing in the research area with Qualcomm, but I'm sure there'll be many, many more. You know, Paul, as I said, got his degrees here at Berkeley, spent a lot of time on our campus, technical, focused on technology, went to Qualcomm, created 25 patents, was the author of the operating system inside the Qualcomm phones called Brew, so made a great contribution to the platform. Moved on into the business domain, has made substantial contributions on the business side, and now is the CEO of the company. I have to say that back last February when he was here, February-March, and he gave a talk, it really made a difference to me. I suddenly got the message, got the Qualcomm vision that the cell phone is the next big thing. Now, we all say that and we all think of it that way, but seriously, I think the opportunity here personally now is we're going to move from sort of working with our PCs and then occasionally using our cell phones to working with our cell phones and occasionally using our PCs, the way that things are going. I really think the opportunity for leveraging that platform is dramatic, and so it's extremely exciting for us to have Paul here to tell us about his vision and where he sees this technology going in the years to come. Paul Jacobs.
So what's a PC again? Let's see here. It's one of these things that takes a long time to boot up. I can't even blame Bill Gates for this. All right, so basically I called this talk not just talk for two reasons. One, because people were doubting that 3G was actually happening. By the way, does everybody know what 3G is, the next generation of wireless? We're going not just digital, but high data rates and lots of applications, things like that. So people were starting to doubt whether this was actually going to happen. People thought, the phone really was, pretty much just about voice calling, and what did it mean to have data coming to your phone, and actually I think maybe we're starting to get over that period where people are having that question anymore. But really, now we're in this period where infrastructure is deployed around the world, and subscribers are starting to use the systems. And the takeoff takes a little while when you have these new technologies, and people are saying, oh, well, do people really want this kind of stuff? And so hopefully I'll give you a sense today that, yeah, this is really happening, and there's a huge amount of opportunities that are available to all of us in driving new applications, new services, new uses of the fact that you have something in your pocket that's got a ton of computing capability, and it's always connected to a network. It can be authenticated. It's got all these great properties to it, and we've built it in a way that actually allows people to put software applications, and we're talking increasingly about other kinds of hardware applications that can go on it. But it's also not just talk, 'cause it's not just about voice, and it's actually the biggest change that's going on in the industry is that we're actually moving from having sold voice, which was pretty much a commodity. I mean, you went to one carrier or another and you got something that was roughly the same thing. Maybe one carrier had a little bit better coverage or a little better price plan than the other. But it was really just pretty much about price. And we're now moving into this mindset where people are selling applications on the phone and data on the phone. And by the way, voice is still the killer app in the sense of it drives most of the revenues in the industry. But now when you go in and you buy a handset, you're buying something that's got a color screen on it, a camera on it, all these non-voice centric kinds of things. So on the margin, people are buying their devices now and their services because of non-voice reasons. And so it's data that's actually driving things. And I'll show you some statistics about how the carriers really care about this, because the voice business, as it is almost in all areas of telecommunications, is starting to go away because it's such a low data rate thing that you're doing. It has some characteristics you need, low latency and things like that, but that's not the driving business going forward. And I've used this chart for I can't tell you how many years, but what I started out with was something that my corporate graphics department drew all of the applications that were on there. And now all of these applications are actually being done by a third-party developer community that we built up around a system that we call Brew, which allows you to download applications to the phone. And it has a whole payment system. And people have made over, we've paid over $350 million already in the first just few years of the system being up and running to developers. So there's a whole thriving developer community that's building applications, and we're doing research here, working on Brew applications here as well as other universities. So there's a great opportunity there. I'll talk to you a little bit more about that. But today, just in terms of getting the raw underlying networks out there, these networks are being deployed, and you can see there's already 187 million people using systems that are 3G. So these are systems that have not just data capabilities, and they're not just digital, but it has reasonably high data rates associated with it. And as time goes on, we continue to improve the data rates over and over. So now you have, actually just recently Verizon announced launching a service here that has 2.4 megabit per second peak data rates, hundreds of kilobits per second on average data rates. And we have techniques as we go on using Moore's Law and more sophisticated receivers to actually continue to improve those data rates pretty dramatically as time goes on. But as you can see from the map, 3G is pretty well rolled out. There is an interesting place where it isn't rolled out, which is Africa, and actually brings up another point, which is what we're doing with wireless communications to help the developing world. And there's obviously some work that's going on at Berkeley around that area. There's work going on in the commercial realm where people are actually rolling out systems now to provide communications in Africa. And so that will happen, but it really has rolled out in most of the world. And the fundamental underlying technology of that is CDMA. So it's a technology that was kind of interesting, and I'm sure as Cal students you'll appreciate this. In the early days of us working on CDMA, there was a Stanford professor who said that CDMA violated the laws of physics. So we decided maybe that only was in Palo Alto. But anyways, as you see, as time goes on, CDMA is going to be the dominant technology. We project 2009, that'll be the time when the crossover point happens. And if you look, also, so these numbers don't quite line up because they come from different people in the industry. But if you look here, we're going to have another 1 billion subscribers over the next few years. And if you look where those 1 billion subscribers are coming from, most of them come from countries with low GDP per capita. So we really are having to drive the cost of cellular technology down. But it's also interesting because with these 3G technologies, we're not just bringing voice to people, we're bringing the wireless internet to people. And I personally, I have this belief that the wireless internet will have a more profound impact on the world than the wired internet will, because more people will have access to the internet through wireless or to data networks through wireless than they will have access on a desktop or a laptop PC. So the fundamental computing platform is going to be a cell phone. And so the first thing you got to do is you got to drive the cost down, because obviously the developing world, there's not as much money there. So we got to make sure that we drive the prices down. And these prices are not low enough yet, and they will continue to drive down. But you can see that we've had a pretty decent decline in cost. And if you think, the low-end phone is a bad phone. I mean, this is the low-end phone that's selling in India for $50. So, or $50 wholesale cost, actually. The carrier then subsidizes it. So this phone also has a version of Brew on it that we call Brew Lite that actually allows you to do some kinds of applications on it. And what we were just talking about earlier is we had this idea where you'd actually even do things like have browsers running on this, have the phone actually be able to talk to a TV set, and use that as a display screen so that you could actually get real computing off of the phone in a very low-cost fashion in the developing world. So there's a lot of ideas about how you take the kind of capabilities that are being built into a cell phone and actually enable a much broader group of people who don't just want voice communication, but they also want data communication. And there's studies about this stuff, about how these things correlate, but penetration rates of voice correlate to higher GDP per capita. And you guys, I know you're all engineers, so you've taken the econ class because it's like an easy way to get an A, right? But anyway, so you know what I'm talking about, right? So anyway, so the amount of money people make per capita goes up. It's correlated with the penetration rate of voice, but it's even higher correlation with the penetration rate of internet. And you can see the kind of numbers. And so the thought is that as you go into these developing markets and you bring in the low-end phone, that's where people will start. But then the economy will improve for a lot of reasons, whether it's because farmers can find out what the right time it is to take their crops to the market for the highest price, or simpler things like finding out the water is good or bad, or things like that. And so the economy in these places, we believe, will continue to improve by bringing telecommunications to the developing world. And like I said, data is a key part of it, because it looks like that has an even higher correlation to improvements in the economy than even just voice does. Now, why in the developing world do we care about driving these data services? It's because the wireless operators are seeing these declines in what's called their average revenue per user. So the amount of money they make off of each subscriber. What this shows is over time, so all the way on your left, the first quarter of 2003. This shows the voice, the purplish is the voice, the bluish is the data revenues per user. And you can see that when they went over 2 years, the voice revenues went down. So it got more and more commoditized. And the data revenues went up. But look what happened in the same quarter when you look at the people who, and by the way, this isn't just an early adopter phenomenon, because it's actually very broadly spread through their base of subscribers. People actually tend to use more voice and more data together when they use the higher speed technologies. And this is the same technology, this one, that Verizon just launched here. And to make the point even more clearly, people talk about how data services and all these kinds of applications are done in Asia, or the United States is behind in data adoption. That's not true. The United States is on the leading edge in terms of wireless data capabilities. in broad deployment. And here's Verizon and Sprint, two of the big carriers, and you can see that their data revenues are going up on very large bases of data customers. So there's an economic incentive for the wireless operator to go out and deploy these technologies as well. And then if we look at another trend that's going on, so we said that the phone is the platform that's going to drive computing, and I also think entertainment and obviously communications, productivity, a lot of these things. But if you look at the numbers that are actually being sold between phones and other kinds of devices that you could use for computing, whether it's desktops, laptops, PDAs, these things, their numbers are just not comparable. And as we go into the developing world where the affordability is so critical, it's a phone that's very rugged and has those data capabilities is going to continue to drive things. So it's not just the high end, it's the low end, the high end, the mid, the whole range of capabilities. Sure, when you go to Japan, you're going to find phones that sell for $800 on a wholesale basis, and they have the most incredible capabilities built into them. But it doesn't take very long before we take those capabilities, we integrate them into a chip, and we bring them to other markets and into the mainstream. And that kind of stuff continues to go into these devices. So they're not just computing devices, but they have 3D gaming capabilities and video codecs and audio codecs and all sorts of really interesting capabilities going into them. Okay, so what's going on? So when I was here in February, I talked about this, and the chart said, I think it was, I compared to a 1998 computer. So since then, we brought the processor speed up. The phone that I showed then was a 40 megahertz processor. Now we're at a 500 megahertz processor. And we have a gigahertz dual issue processor coming out. So roughly the equivalent of 2 gigahertz in the palm of your hand. It's a pretty amazing concept that you can have that kind of computing power. And of course, power consumption is a key issue there. Well, we're driving the power consumption down as well, so that this actually is something that will work in a cell phone. And you put things in there like dual processors. So you have a processor. All you IC guys know that you can't simultaneously optimize for high performance and low power consumption. So what happens is we have a high performance processor and another processor in there that's low power consumption. And the low power consumption processor is the one that's running the phone most of the time. And it lights up the high performance processor every so often when it needs to do something like a video decode or some complex calculation, so forth, and or video encode. And so you can save power in the phone. You've got to manage power very carefully, obviously, in a handheld device. Some of the other things that are amazing about this is you look at the kind of memory storage. So memory is the component in the phone that's decreasing the fastest in cost. And we just saw, for example, the announcement of hard drives now that they basically got a 10x improvement in the density of data that you can put on the hard drive. And there are already, as I'll show you in a second, there are already phones out there with hard drives, which isn't such a crazy thing because, I mean, a lot of you, I'm sure, have iPods that you carry around a hard drive with you all the time. So the notion of a hard drive in a portable device, a small portable device, isn't that crazy anymore. But these things are going into cell phones, as well as in this case, where you have solid-state memory and 2 gigabytes of solid-state memory going in here. But here's another interesting thing. If you look back and you compare this phone to that PC, is the data rate of the connection to the network. So you were probably still using a dial-up connection then. You kind of got 56 kilobits per second when you were lucky. Here, this thing has a data connection that's, this 2.4 megabit per second peak data rate kind of connection. So the capabilities that you have in the phone now, both on the processing as well as the connection into the network, are just amazing. And then you have all this authentication. You have a micropayment billing system that's associated with it. So if you think about a cell phone call, when you make a call, that you're essentially making a commercial transaction with the wireless operator, and they're billing you a small amount of money for that. So think about what that means in terms of other things that could be sold on the phone, and that's actually what we did when we built this application download process. It's all authenticated. You have complete access to the phone because the way the security works is that we actually know who the developer is, and if you cause a problem, then the app can get revoked off, and there's a financial penalty, and so on and so forth. So it's an interesting thing that's happened is that, and we were talking about this on the way down here, is that as we're building technologies, we're thinking about the business model almost before you think about how the technology gets built. And if you think about trying to prove that an app is not malicious or not buggy, I mean, you really can't do that. But what you can do, I mean, you can do it under limited circumstances, but in the general case, it's a problem that's not, you can't solve. And so what you do is actually keep track of who the developer is. The phone has cryptographic algorithms in it. It knows, so if the app has been compromised, the app doesn't even run anymore. So now I know that nobody can embed different code into an application. And then I also know, so I can trace back, if something happens, I can trace that back to the developer. And I also can trace back when they want to get paid, they get a check. So every month we're actually sending checks out to developers, and it works, the whole financial part of the system and the technical part of the system work together. And the nice thing about this is that unlike what happened with Java, where you tried to protect the device from an unknown application, here we allow complete access to the guts of the phone, so that game developers are really excited about this because they can, they want to program as close to the metal as they possibly can. And by combining a business and a technical aspect to it, we were able to do those kinds of things and allow that kind of access to the phone. So I don't want to go over this in too much detail, but the system's actually been rolled out with a large number of operators, a large number of device manufacturers, and there's a lot of people who are working on applications for it. So I talked about the phone being like a computer, and you say, okay, well, memory. We talked about memory. So this is the phone that's got a 1.5 gig hard drive in it, soon to be a 40 gig hard drive as soon as these 1.8 gig, 1.8 inch hard drives come out that have this new recording technology in it. What other things do we have? Well, we have a user interface. So how do you get stuff into the phone? Well, I talked about one idea where the dock is a keyboard, but you don't want to carry around stuff like that. So phones are increasingly have other ways of getting stuff into it, whether it's small QWERTY keyboards. I don't know how many of you guys use BlackBerries. Is that popular or not that popular? Sort of popular? No? Does anybody know what a BlackBerry is? Okay. So anyway, so these are coming out on different devices. This phone, the phone that we did as a reference design, looks like a phone. You slide it one way and it's got a keyboard in it. Slide it the other way, it looks like a phone. This is a PDA kind of device where you slide it down and the keyboard's there. So you actually have the ability to input a fair amount of text. People always talk about things like voice recognition, and I just have a cautionary tale because I used to use a Newton, which maybe you guys don't even know what that is, but Newton? Okay. So it was this thing that PDA where you did handwriting recognition on it, and when they first launched the thing, it didn't work at all. But by the time that they had the last one, it actually worked pretty well, but nobody would buy them anymore because your average consumer sort of got turned off to handwriting recognition. And so speech recognition is kind of in a similar boat. We're doing very cautious things about putting speech recognition into handsets, because if we do something too full-blown and your mainstream consumer says, oh, well, that doesn't work, well, that's going to set the whole industry back for years. So I think keyboards are probably the best way to get stuff in, but there's other kinds of ways to get information into the phone as well. The most interesting thing, I think, though, is these phones now that actually connect to the TV. So this phone, which is another phone I'm going to show you in a second, is a camcorder phone, and it actually comes with cables that plug into the TV. And they do it today because you want to show your pictures or your videos that are on the phone to your friends. But now imagine I have 3D games, console quality 3D games that are running on the phone, or I have a computer that's running on the phone and a web browser and all the various kinds of applications. Those kinds of things will be shown to the display as well. And as we think out in terms of the kinds of wireless data rates that we're going to get in the short area, local area, we're going to actually have screens now that'll, because there's flat screens, people will want to put them on the wall where they want them, and they'll actually accept video streams over wireless through digital connections, and the phone can now participate as a partner in that. So you can imagine, say, I don't know, 4 or 5 years, you'll walk into a room, maybe it'll happen quicker because technology always sometimes surprises you that way, and the phone will just light up the screen on the wall and you'll be able to do whatever it is you need to. So when you start thinking about this idea of the phone sort of taking more and more on about what the PC does, think about it not in terms of a 2.2-inch screen on the phone, but think about it in terms of the capability to light up a high-resolution display that's on the wall somewhere. So you opportunistically get access to that. And so that's how the phone is actually going to escape the kind of, limitation that you get from the fact that it's really the form factor, the fact that you want to carry this thing in your pocket, that's limiting how big a phone can be. And it's actually funny, too, if you look at some of the leading edge markets, this is a phone out of Korea, phones are starting to actually get a little bit bigger because people want to have a little bit more screen, but there's a limit to that. And we don't want to end up with something this big that we expect people to carry with them all the time. And when it comes to user interfaces, the phones are actually changing. So as this phone looks like a camcorder phone, there's other phones that look like game-playing phones, and we have one that we've done as a reference design here that's got the joysticks in the right place so you can play it, and the buttons up here. And so what I think is going to happen over time is that people will start to choose phones based off of some attribute that they highly value. And over time, you'll have multiple phones and things like that for different reasons. Now, the phones do all sorts of other things. So this phone being a game-playing phone also is an MP3 phone, also has a camera in it, all those other kinds of things. But it's the question of what's the emphasis on it based off of the hardware design of the phone. So we're seeing that happen in a big way. And if you think about these phones also, so the capability that we're putting into the phone right now in terms of 3D graphics is between a PlayStation 1 and a PlayStation 2. So the kinds of graphic quality that you get on the screen is amazing. Now you think about a phone that can plug into the TV set. And think about the developing world where video game consoles haven't really taken off. Now there's a way to actually go and have video game console that's essentially your cell phone. So that's another piece where all these things come together, along with the application delivery model, along with the ability to sell the applications. All of these pieces come together to make the phone be a more compelling platform for entertainment as well as computing. And of course, we're putting GPS into the phones also. So these are phones for little kids with a few numbers on them, or for a person if they fall down and they press a button and it calls somebody and they can figure out where they are and have them come and take care of them. So phones are starting to segment into other markets as well. But this idea of having GPS in the phone, so the government here actually required that phones have the ability to be located. And so if you make a cell phone call to 911, they can actually figure out where you are. And that's been a process that's been happening over the last few years. And just now the carriers are getting around to opening up the platform so that an application developer can put applications on it. And some things that have happened in Japan, for example, where they didn't have this mandate, they actually put it in because they wanted the application. They have navigation. So this is a navigation system that's not just like a car navigation system, but it's also got things like subway schedules in it and how long does it take to walk from one place to another, and bus schedules. And so it actually works for a person to figure out how to get from one place to another, not just driving from one place to another. And they do all sorts of crazy things like keep track. There's one application there that if you stay at work too long, it knows, and a little character comes up and nags you and tells you to get a life. So
I think your wireless mic might be off.
Oh, can you not hear me in the back?
Yeah, we can hear. We're recording you though. We need to record.
Yeah. Can you just check the switch? Thanks.
The wireless technology, I blew it. All right, I'll start over again. Is that what you? All right, so, but now I'm a lot louder. So anyway, so they put all these things in, and then they've done some really interesting things also with the camera. So I'll show you in a second. They have this application actually where they take barcodes out of media, and they actually use that as a way to get information into the phone. So you have a magazine or an advertisement for a place to go, and it's got a 2D barcode on it. You take a picture of that with the camera, it actually brings the information in, and then it can tie it into the mapping application and tell you how to get to that place. So it's kind of interesting mixed media things that are going on by using the cameras. And here's an example of one of those cameras. So this also is an interesting comparison to when I came in February to talk about this. So when I came in February, there was a phone just came out that was 5 megapixels. And this is 7 megapixels. So you look at this thing, and that thing looks pretty much like a camera, except you turn it over, and now it looks like a cell phone. So this one's, again, more optimized to the to the camera application as it is to some other kind of application like the gaming phone or these other phones. And that's, I think, a trend that we'll see more and more happen. But once you start having that kind of resolution on the camera, you can do all these interesting things. So, like I said, this application with the 2D barcodes, but they actually went beyond this application. They have a really interesting one now, which is you take a picture of text, and in this case, because it's Japan, take a picture of English language text, and it does optical character recognition and translation and gives you the Japanese translation of it. Isn't that a cool idea? And so people are coming up with all these really interesting things. We actually did one where we were using the camera to act as a mouse. So it took image flow information as you moved it around and actually controlled a cursor on the screen. And actually, it doesn't quite work because these cameras sample at a much lower rate than a mouse does. But over time, you can actually imagine making that kind of a thing work. So you can actually use it to do things. And then people are talking about all sorts of interesting things like glasses that'll actually do the translation with the camera. And there actually finally does exist a pair of glasses that doesn't give you a headache and is very cheap. And you'll start to actually see these things come out. And you'll have to decide whether you really want to look like a super nerd or not. But you'll be able to wear these glasses and see information. So this is the phone that I was showing off, this one that's got the video on it. So you think you have this incredible camera capability in there. You've got this incredible amount of memory in there. You've got the connection out to the TV. So we're actually building phones that are the equivalent of a DV camcorder. And when I was here in February, I actually said that this was going to change the way news gathering was done. And then when the London bombings happened, it actually happened. So news crews couldn't get into the subways where the explosions happened, and people were using their cell phones and taking pictures with their cell phones, videos with their cell phones, and taking them to the news station or sending them to the news station to be put on air. So now imagine, it's always amazed me when you think about the fact that video cameras aren't all that popular, and whenever some crazy thing happens, there's always somebody's got a picture of it. I never understand how that happens, but somehow it does. And now just imagine every time something happens, there'll be somebody will have their cell phone. They'll be able to take a video of it, and so there's a lot of interesting implications of that for whether it's documenting human rights abuses in the developing world, or it's news gathering, or whatever the implication you want to think of, or blogging. There's very interesting things going on the blogging front. So people are using the video, they location stamp it, they put it on a blog with the location, then your friend comes around, sees that blog related to a location. So as an example, I could go to a restaurant and leave a note for my friend that says, see this restaurant here? Don't go there, go down the block. And when they get into that location, the phone could tell me that there's a blog entry waiting for me in that location, and I can view that. It's kind of, that, you can really imagine taking social networking and building a really interesting kind of community sense and giving you a lot of context about places, not only places where you've been, but maybe places where you haven't been. You go to some new town, and you can have information that's been left for you around by people who have the same interests as you do. A lot of interesting social implications to these things. So one of the things that's really big now, one of the next big trends that we're working on is obviously multimedia. And so one of the areas that's been happening in Japan also, because in Japan, a lot of these things start in Japan and Korea because the consumers are willing to pay more for their phone. So stuff gets put into the phone before it's all integrated into the chipsets, and therefore the cost comes down. So they get these services earlier on. But what they did was they built an FM radio into the phone. So there's this app that runs on the phone. You tune the phone, gives you information about what song's on. Okay, that's kind of interesting. But then what they did was they actually built it to their download site for ringtones. And they have real song ringtones because they have the data rate to download real music into the phone. And when the song comes on the radio, it tells you, oh, if you want, you can buy this ringtone also. And now they just launched their full music download as well. And I forget what the exact statistics were, but it was equivalent to the kind of downloads that iTunes was getting, but it going onto the phone. So you can see the phone now will increasingly be more important for entertainment as well. And all this notion of integrating broadcasting into the phone is another area where I think we'll see a lot of excitement. And it's interesting if we look at things like video onto the phone. So video turns out to be one of the applications that people are most interested in having on the phone. So you can see sort of what this says is how much people prefer video over these different applications, whether it's camera, having internet access, push-to-talk, instant messaging, games. Games I think are important anyways, but we all know that it's more of a niche market. It's the people who are into games, they're really into them. But for most people, maybe they'll play a few games and it's not so exciting. But video looks like it's important. I mean, pretty much everybody in America watches TV, so now we're just going to put TV on the handset. And it's a very interesting thing because as we looked at it, you could run TV over the standard cellular network. But the problem is you can only run so much because getting a very high quality video stream is about 100 times more data than it is to run voice. And what we found in Korea, for example, was that consumers only want to pay a flat fee. You don't want to pay more money the more TV you watch. So now we're saying consumers will pay a flat fee, but they want 100 times more data. So how do you do that? So the way we're doing that is we're actually using broadcast systems to broadcast video down to the phone, and we've actually built a system where it looks just like TV on the phone. So you have an electronic program guide on the phone, and you can actually switch channels, and you can see. No, I don't want to. There we go. So you can see various shows on the phone, and this one's actually cached on the phone, and it's a combination of caching and live over the air. And so we actually have a whole set of protocols for discussing how clips are linked together, but how a clip might be linked to an application. So for example, and how it might be linked to an alert, so we have metadata. So this is an example where, say there's a news show or a financial show, and they mention, well, this might not be as interesting to you guys, but it will be in a few years. So they mention a stock, say Qualcomm, on one of the financial channels. And it says, okay, well, some news came out. My phone can buzz. I can open up the phone. I can see the video clip. There can be a soft key programmed at the bottom of the phone. Press that button, it brings up a stock trading application. All of that kind of in one, very easy to use way, because the way that cell phones work, cell phones are a very mainstream application, and the key to making applications useful to people on a cell phone is make them very simple. So we're really trying to make things be very integrated together, use it in a paradigm that they expect, meaning something that looks like the TV, they can channel surf and things like that, instead of having to go into a browser and look up a certain clip, download it, wait while it downloads, ho-hum, okay, it's finally there, look at it, and it's 2 minutes long. This way it'll actually be coming to you all the time, or it'll actually be on the phone at the time that you want to go look at it. And so basically built this so that it actually runs over many different networks. And this is actually, I started out talking about 3G, when I think about what 4G is going to be about, it's really going to be about how to get data to and from the device over whatever network it is available and at the lowest cost. And so what this system actually does is that if there's a few people who want to watch something, it runs over the standard cellular network. If there's more than a few people, and it doesn't take a lot because it's much more efficient, it actually runs over a broadcast network, much like a TV broadcast network where there's only 2 or 3 towers in a given metropolitan area, and we actually blast that information across the entire city and into the cell phones. And so it's actually this natural thing where you can use different kinds of technology to get information to the phone depending on what the cost is and what the consumer is willing to pay. Obviously, if I want to watch some particular thing and I'm the only one who wants to watch it, yeah, the cellular network's the right way to do that. But if there's a lot of people who want to watch something at the same time, say it's a sporting event, then the cellular network gets overloaded. And you need to use a different kind of topology. So you should think about that when you think about how networks are getting built out. It's not just the radio link anymore. It's actually the whole notion of what the topology of the cell is as you build it out. And so, as I said, we've built different technologies. We've actually even built broadcast technology into the cell site, or into the cellular technology as well. And so there's many different ways that you can lower the cost, and each one depends on the particular application. And that kind of goes back to the original thing that I was talking about, which is it's almost like the application and the technology go together now. It used to be we build technology to get more voice calls or more data rate, and now we build this flow technology with this broadcast technology by thinking, how do I make the channel switching time a second instead of 10 seconds? How do I get power consumption down when I want to see lots of channels? And so it's actually turned almost around now. We don't now build technologies just for the sake of building a technology. We build it because we know there's some application out there that we want to go out and try. And so to kind of close, the next big thing for the industry is this convergence of the phone and other types of devices. And if you look around, there's all sorts of different devices that have already gotten put into the phone, whether it's the camera that obviously the voice telephone, the pager are in there, the PCs going in the game console, talked about FM radio, but also interesting things that are happening right now, things like glucometers. So people are building glucometers into the phone, and the idea is that if a parent has a diabetic kid, they can know that that kid has tested and that they're within range, and so they can sleep a little easier. And there's other kinds of applications. We've been talking about how do we actually go impact the healthcare industry as a place where there's a lot of money being spent, not terribly productive in a lot of ways. And so that's kind of another frontier. And so as we think about what the phone can do, you should think about all the different kinds of things that can get integrated into it. And now, as you think at being at Berkeley with integrated circuits and MEMS and all these kinds of technologies that you're working on here, those are the kinds of technologies that will be built into the phones of the coming years. And so that's what the world's going to in terms of a handset. So let me just close by saying, go Bears.
Well, that was absolutely fantastic, and it covered a lot of ground. I didn't mention at the beginning that Qualcomm is now, over $5 billion, and it is the largest fabless chip company in the world. It builds more integrated circuits for a company that does not manufacture the chips than any other company in the world. So it's a fantastic success. Before we open it for questions, we have a token of appreciation. And this is for the man who has everything. So we decided to give you some gifts for the family.
Oh,
this is for the kids and for your lovely spouse. So, and the only reason we give him a very big box like this is Paul did come up in his own plane, so he can carry them back. So we'll give you that later.
Thanks a lot.
So now we're ready to open up for questions. We have a microphone here. Yep, here's one in the front.
So you talked a little bit about micropayments, but we really haven't seen...
Can you use the mic because we're videotaping this.
You talked a little bit about micropayments, but we really haven't seen too much of that in North America for things other than buying software applications. I can't say use my phone to place a McDonald's order and then have it already waiting for me when I show up there. Why hasn't that shown up in North America?
So there's micropayments and macropayments, and macropayments haven't shown up yet because the carriers don't want to take the credit risk of having those things on your cell phone bill. But that will actually happen. I'm very convinced we'll get either the operator will do it or some third party will do it, and therefore that credit risk issue won't be there. But in terms of things like integrating the systems to get payments of things in the real world, where you actually go to a place, then you have to build the whole fulfillment system. And people are working on those kinds of things. Now, the one key issue is what will consumers accept? And if you look at all the digital money experiments that have been done in the United States so far, few of them have been very successful. And I suspect that it may take a change in generations before people feel comfortable with that. Much like what happened with ATMs. People started off saying, I won't use an ATM, and now they won't use a teller. So these things can change over time, but with anything that you deal with the consumer, you can't tell ahead of time what the consumers are going to adopt. It's just very hard. I always tell people if you knew what a consumer would adopt, every Hollywood movie would be a blockbuster. And obviously they aren't. So you got to try these things. You got to build systems that are flexible and be able to make changes to them, and that's kind of what's going on right now. So this is happening in other parts of the world. There are systems in Japan and Korea where they're using RFID type technologies for payments, both macro and micro payments, and I think that stuff will eventually show up here. But I do think it'll take time for consumers to feel comfortable with it.
Okay, another question? Here we are, back here. Send the mic back.
So currently, it seems like the cell phones get obsolete really quickly. So you have a new one coming out this season, and then 2 years later, that phone's obsolete. So is there anything being done to make the applications or the firmware more flexible so the lifetime of this phone with so many different features in it will be longer and will stay on the market for a longer period?
So it's a bit like the PC, where the new phone will have the higher megapixel camera, or will have the better processor, more memory, or things like that. So I think that won't change for quite some time to come. But we are doing things where you can download applications to the phone, so that if the phone didn't, when you bought it, didn't do instant messaging, you can buy the instant messaging application, or you can buy some new game on it, or you can get certain kinds of services. But a lot of it's going to depend on what the underlying hardware is. And at the end of the day, people drop their phones, and the phone naturally has a sort of a lifetime just based on the durability of it relative to the kind of usage that people give it. So I think, we try and balance those things off. And 2 years is actually kind of on the outer edge right now of how long people keep their phones naturally. It's in the United States, it's somewhere around 18 months. Places in Asia, it can be even sub a year. So I think that's kind of a natural cycle that happens in consumer electronics. And I have to say, from our point of view, our business model point of view, we sort of like that. But so please buy more phones.
That begs another question, which is, so as this thing becomes more like a PC in terms of complexity and compute power, there's things like backup, there's things like how do I port my apps from one phone to another.
Right.
And right now, that sort of, I'm the consumer, I have to do that through my PC platform typically, which is pretty clunky and not very efficient. Are people thinking about that and providing sort of automatic backup services, and I have some home in the net that can reload a phone for me?
Yep.
And then the other question that comes up is then the whole legacy question. At what point do you get sort of stuck like Microsoft is, in the sense that you can't really do much anymore because everybody depends on your operating system? So you can't really extend it.
Okay, let's see. So let me remember all these questions.
Okay, sorry.
So backup, actually, there is backup today. You can buy an app on Verizon, and it backs it up to a website, your numbers up to a website, and you can re-download. In terms of applications, what we're actually finding is very interesting is that so we have different pricing models for applications. There's one-time fees where you buy it up front and then you own it, and then there's subscription models where it costs much less, but you pay on a monthly basis. And we find that people predominantly do subscription instead of purchase. And I think the reason is because they get rid of their phone, they want to get a new phone, they don't want to think that they paid so much money up front and they own that application, and now they worry about, will it work on my next phone, or things like that. In Brew, we did try and build in some systems to allow you to say, okay, well, I own this application, and can I use it on the next one? In terms of compatibility and backward compatibility, obviously there's some issues associated with that, but one of the things that we did within the system also was we allowed it to be dynamically extensible. So we don't make a decision, and a standards body doesn't make a decision about what feature necessarily goes on the phone. We can make up some, but every developer is able to make up their extensions, and then they can advertise them to the rest of the developer community to use them. And it's really up to the carrier to say, okay, that extension can go on my system or not. You might think, oh, well, that's going to lead to huge fragmentation, but now you're forgetting that the phone actually has a connection to the network all the time. So when I download an application, if my extensions aren't there, they can be downloaded. And so we can build backward compatibility that way as well. And so I spent a lot of my time in my early part of my career at Qualcomm going through standards bodies, and I got to tell you, this really is sausage making, and it's a lot of what happens is the big companies that are there, and we're one of them now, obviously, get in there and they're not necessarily there doing things for technical reasons. They may be slowing things down, and if you want to get the kind of experimentation that allows you to figure out what the consumer really wants, you can't wait for a standards body to chew on something for 2 years and then spit it out the other side. So we built this system that just allows anybody to go do it. And now you have to go convince the carrier to let you put this on the device, but that's kind of natural. They're subsidizing the device. They're worried about people harming their network. There's a bunch of reasons why they want to have some degree of knowledge about who did the application and what the quality of that application is. But I think the system, so far has worked pretty well. It's not perfect. Obviously, the carriers get in the way of things, and they'll slow down the process a little bit themselves. But they at least have a commercial incentive to try and get things out quicker.
Question there? Send the mic back.
I think by the way that a cellular network is designed, essentially with a low-power handset and a very high-powered tower, it's much easier for content to be transferred from the network to the phone. But what opportunities do you see for phone-generated content either to go back into the network or go from phone to phone in a sort of a peer-to-peer sense?
Okay, so going from the phone to the network, I mean, that's actually a big issue right now. So the first networks got built with very asymmetrical links, and now we're doing all sorts of things like interference cancellation and more. The thing about the receiver and the base station is we can use more power there as well in the processing. So we can do really interesting things there. We're even looking at doing things like building using the cellular network itself as a set of sensors to do interference cancellation on a much broader scale. And you actually start to see when you use receive diversity and multiple antennas and interference cancellation, you can get very high data rates in the uplink as well. And obviously, with things like cameras going on there, there's going to be an awful lot of user-generated content. So it's very important. You haven't really seen it hit that strongly yet, but it will be over the next couple of generations of technology.
Okay, another one. We're going to follow the mic here. Do we have a mic over there? We don't, right?
We have two over there. There's one.
Oh, okay. So once you get that mic going back there while that one goes over there.
Yeah, I had that problem too.
Okay, yeah. Actually, I just want to add on to the question that came back up before the last one. I'm a Palm Pilot user, and then I have a separate cell phone. The one aspect of it that is enormously important for me is my ability to synchronize data with other infrastructures that are around me. For some people, it's a corporate time calendar. Some people, it's an Exchange server. I want my Quicken my transactions and synchronize with my Quicken so I can do my bookkeeping when I buy all my lattes in this new building. That basically has two aspects of it. Is the physical media, basically there has been USBs, there's been infrared also, and then there's the other thing is the conduit, the device being able to speak the language of the other infrastructure. What's your philosophy on that? Where it's going, both like the hardware end of thing, the physical media, and then the other thing is also whose responsibility is to have those conduits, and how is that? What's your business model for that?
So it's the developer community's responsibility for building those conduits. I mean, we made a pledge to the developer community that we weren't going to go build applications, general applications, because we didn't want the developer community to think, oh, here's Qualcomm, they'll go build this platform, but they're a big company, they'll figure out what's really popular and then do it themselves. So we told people we wouldn't do that. So we've left it to the developer community to do those things. I mean, we have internal applications that we built for demonstration purposes or for our own use or things like that. And so I can synchronize my calendar to Exchange. I can synchronize my email to Exchange on my phone through a Brew application. In terms of the physical conduits, there's certain aspects to it that the carriers are trying to control because they're worried about security and they're worried about what they call revenue leakage, the fact that you might put files onto the phone. But that's actually going away more and more, and the carriers are actually opening up the platform to allow things like music to be downloaded onto the phone. And that's, I think, a progression over time. So as they're allowed those kinds of things to happen, they'll be more likely to put more kinds of links on the phone. It's a really interesting thing for us that we put Bluetooth capability into the chipset very early on, and it didn't really get used in the United States at all. And so if we go back and look at how much money, we probably spent $40 million of silicon putting Bluetooth in that never got used. And so it's a very hard problem for us to make this decision about when you integrate some kind of feature, when you leave it outside, how do you implement it? Do we do it or do we work with a partner? And it's actually, we do that on a case-by-case basis now, and it's not, I don't have a cut and dried method for making that decision right now. It's very ad hoc at the moment. We look at every single case and make a decision about whether that'll get put in. And then you have to work with the operator, have to work with the handset manufacturers to make a decision about, will they build a phone using these kinds of technologies or not. So there's not a simple answer to it.
Last question, back there. Got the mic?
You showed some slide envisioning great growth in the developing countries and poor countries. But I guess applications like video cameras or video games would not really be suited for those countries, at least for the next few years. So
Depends
how
on the cost. Yeah.
what?
Depends on the cost, but yeah.
But how do you think developing countries can benefit from 3G beyond voice?
Yeah, so I mean, there's a whole bunch of data applications where you can imagine, for example, farmers knowing when to send their crops to the market is a classic example, or finding out information about if there's some weather. Well, it's very important issue for us right now, but knowing that some weather is going to happen, or various things associated with the world around them that they just have no idea about if you're living in an isolated village. And healthcare is a huge application there as well. And so I actually do think that there's a role for some of these more sophisticated applications. Maybe they are at the higher end of the market in the developing countries, but as the economies improve, then more and more people will have access to them. And the other thing that will happen is, as Moore's Law keeps driving forward, those things, and we continue to integrate, those things get cheaper and cheaper, so they get pushed down into the lower end of the market, and so they become more affordable in the developing world. But look, this is not an easy problem, and I would say that in a lot of the developing world, it's probably going to be one phone will get shared among a bunch of people, and maybe somebody will build an application that keeps track of that. And so that's the kind of thing where a data application could help out in the developing world. They can do things like, so I read about in Africa, some people go in and they'll buy a prepaid phone, and they actually SMS the credits around to each other. So one person buys it, and then they kind of set up their own economic system there for sure. So all those kinds of things can happen, and as long as you build a system that allows for creativity and flexibility and experimentation, a lot of really interesting things will happen. If you try and lock things down and make it all go through some slow process, then yeah, I think we won't have the kind of innovation that you've seen here. But that hasn't been a problem in the wireless industry so far. I mean, things have been moving pretty fast. So I think it'll move both at the high end and the low end.
So we're going to have to draw it to a close here. We have the reception outside. I invite all of you to come out, and Paul's willing to take additional questions if you have any. Again, on behalf of all of us, Paul, I'd like to thank you very much for a fantastic presentation.
And one thing, Qualcomm is hiring, so.
And thanks to Qualcomm for that cyber cafe. We're going to all make great use of that, I'm sure. So.